These look interesting. These are, in fact, DIS 1417 hexadecimal displays. And the way they work is that you give them a hexadecimal address and then they display the appropriate digit. And for anyone who's particularly interested, there's the numbers on the bottom. And apparently they're made in Korea. In any case, I think they're definitely working. But they're working in the wrong tense at the moment. I've got to reverse the polarity of the neutron flow. You know, I think I've cocked this up. Let me try something. Okay, by the magic of switching over the positive and the zero, I've actually got it working the way I was expecting it to work. When the switch is on now, it pulls it up, whereas previously it was pulling it down, so the displays were displaying the wrong way. These are going to be really useful. Essentially, the displays can be dropped on a data bus or an address bus, and you can see the value that is being output on there without having to do any binary maths with LEDs or anything like that. They were expensive at £3 a pop, but I've seen them a lot more than that. The main problem with these displays, as I see it, is that they are oriented incorrectly to be useful, or rather to be useful on breadboards, to be more precise. Obviously, having a vertical stack of these devices takes up a lot of space on the breadboard, and it doesn't make for easy reading of the bus numbers. So I built a display unit, and this display unit is essentially a 24-bit bus monitor. So that would allow me to view a 16-bit address bus and an 8-bit data bus at the same time on 6 different displays. And those are displays. So I'm going to attach this to the processor board that I set up previously. Let's try the power again. Oh, it's counting. I wonder if we reached that. So we do still have a problem in that although it works, the reset isn't working, and the display seems to think that the data bus is at FF, which doesn't make sense because it isn't. Let me try. So what I'm going to do is just try moving some of these resistors from where they actually are into the other rail. Just okay, I think I've worked out what the reason was why that display was showing FF. The connections just here were being pulled down to ground via a resistor rather than being directly connected with a wire. Although it was pulling the data bus low enough for the processor to tell what the voltage was, the actual monitor needs a harder ground, if that makes sense, a lower voltage. And then we do that, which is weird. No, have I got a dodgy connection? Oh look, I've got a dodgy connection here. Okay, so again, crappy prototyping boards. When I reset the processor, the address drops to EAEO, as you can see every time I do it, via another address, which I can't quite read, but that's okay. EAEO. So if I was to write any firmware or any sort of programming or anything like that, I would probably need to start it at address EAEO. Maybe. We will see. But as we can see, the program counter is now working, and it's working in a manner that we can tell without having to connect up the oscilloscope. And we can see that the instruction on the end, the last two digits, is the data bus where the instruction is connected, and we've hardwired that connection to be a no-op, which is EA, or if I can get this right, 1110 1010. Is that right? So that's interesting. When it gets to FFFF, it just goes back to 0000. I wonder what happens if I switch the clock off.